Hi. How many of you guys are familiar with RLHF? Raise your hand if you're familiar. Okay. Raise your hand if you'd still like sort of an overview. You're not too technically focused. Okay, cool. Yeah. You'll notice that just like Anthropic, I dropped the honesty. It's still there on the little booklet, Encoding Morality and Honesty. But here I'm encoding morality and reward models through reinforcement learning with human feedback with explanations. What is this term? What is RLHF? What is reinforcement learning from feedback? Essentially, we take feedback. So we're like, oh, the model generates a prompt. This prompt is the better prompt. This prompt is like the worst prompt. And after it's used, this is the form of reward model. This reward model is supposed to represent what humans want in some broad, vague sense. And then afterwards, you optimize a policy against it. It's very rooted in this sort of idea of you can reveal someone's preference. However, sometimes RLHF models don't work that well. There's sort of the empirical alignment technique that we have right now. Most of our other techniques rely upon like evaluating models or like trying to study the internal activations, which is a little bit like evaluation. But RLHF models, we can just like bash a language model against a reward model right now. However, sometimes it doesn't work. Sometimes it reveals sensitive information, spreads biases, hallucinates untrue content. And I think generally people in the safety community would agree that it's not good enough in its current form. And that it probably, even if it's improved, won't be complete. It'll only be one Band-Aid and a larger solution. So typically, this is what's the figure that's used to explain how RLHF works. But instead, I created a simpler figure for you. You have preference pairs, chosen and rejected pairs. You go ahead and you use that to train a reward model. You give it something like, give the preferred one a high number, give the rejected one a low number, and afterwards that reward model is then trained. And now you can go ahead and use that reward model and high number, good, low number, bad, train the actual model that like generates a response and it rates all the responses. And the hope is that this can be used to update the actual model. Yeah, this is the actual loss function. I'm hiding a bunch of the math from you. That'll be the case throughout the entire presentation. Some key concepts from the RLHF literature are reinforcement learning from AI feedback. A lot of times humans are the ones that have to like label the preferences, and that can be really expensive. And so Anthropic was like, what if you just have AI generated harmlessness pairs? And so that is like a paradigm that I might use / borrow / steal. And another thing is high dimensional human feedback. There have been sort of comments around like, outside of just binary human feedback, you can do things like ranking models or like giving a 1 to 5 scale. And some of these have been tested out to a limited extent. Now we're using RL here. And one of the problems with RL is that there's a phenomenon that occurs called reward hacking, right? The reward model is like somewhat flawed, or like the reward function that we defined is somewhat flawed. And we can see analogies of this, right? This boat is over here finishing the race, maximizing the amount of points that it can take. Or this robot is moving forward. Look at that. It's walking forward exactly what we wanted it to do. We have like tons of examples of this occurring in reinforcement learning. And the question is, does this occur in natural language as well? And the answer is absolutely. Reward models are currently not robust. They suffer from the technical terms of like overfitting, lack of robustness to spurious cues, susceptibility to reward hacking. All these sort of symbolize this thing where it's like a reward model doesn't quite work and it has all these quirks. And to mitigate this, we try to minimize the sort of Kale divergence, which is this statistical estimation of like the difference between the the original model and like the RLHF model. Because if you try to optimize too far, so you try to increase Kale divergence, you would expect that the reward model would get better and representing a human. It would eventually be like it would only just make things that are like humans prefer, but instead it reward hacks. It starts generating nonsense in the language form. And so you'll notice that this is, the example here is like the OpenAI summarization task. You were tasked with like summarizing and like rating summarizations. And eventually, as Kale divergence increases, you just see like this jumble of words that don't quite make sense. And it's pretty clear, at least to me, that reward models lack this true understanding of what humans would want. And I contend that a lot of the reason why is because pure preference data isn't sufficient enough for LLMs to fully understand human morality or preferences. They require richer, more information-dense forms of human feedback. And this has actually been done before. I think Llama 2 uses like a separate safety ranking, a separate safety score, and ranking of various prompts have been done before, which is richer than like the pure preference pairs. And I think a lot of my idea was, what if you attach a natural language explanation to a preference in the current RLHF data set? We literally just explain to the model what we want. Would that improve robustness? Would that make it so that way certain spurious cues aren't picked up upon? There's like all these sort of tests that you can do. Or you can see whether or not it incentivizes or doesn't incentivize certain failure modes. This slight modification, of adding explanations. And the hope is that we can do it in our own natural language with our own priors, things that language models are built to understand. There was this paper that was released by Stephen Casper and Xander Davies from MIT and Harvard. It had a much cooler title before. It was called RLHF is Not All You Need. But now it's just open problems and fundamental limitations. All right. They wrote this paper, and a bunch of other people. That's my wait. Oh, I guess I didn't show, but yeah. My mentor, or like one of my mentors, was also on this paper. And they essentially criticized a lot of RLHF literature. In particular, they criticized things that you or I might criticize around an individual's human values being difficult to represent with the reward function. Can you really use this sort of assumption? Is this assumption even correct? And reward models, even if they have like correctly labeled training data, they can generalize to be poor reward proxies. They can have these sort of quirks that are easily exploitable by the actual language model. And not only that, they actually mention the possibility of translating natural language specifications into a reward model, an idea that I came up with in around February or March and sent over to Herbie, who's right there in the back. They actually mentioned that this is a possibility, but my exact setup might be slightly different from what they were envisioning. But yeah, it's quite similar: encoding, morality via explanation generation, and natural language feedback. So there are two main things here. The first one is having high dimensional feedback. You'll see like red is sort of what I added on top. So attaching a natural language explanation to a preference in current RLHF data sets. And the second part is explanation generation. So taking a reward model and having it output not just a decision or a reward, but also an explanation for why that reward or decision was made. The hope is that A, it can make preferences more robust. The preference model might be more likely to understand what humans would prefer. And second, if it fails, hopefully, if we make the chain of thought somewhat faithful, or we design the model to be like a two-headed transformer, you can provide some sort of preference transparency via natural language explanation of why one thing was preferred above another thing. And the hope is that I can expand the scope of this task to focus not just on the conventional RLHF tasks like summarization, but also stuff around ethical dilemmas, helpfulness and harmlessness, and truthfulness, hopefully creating a very robust reward model that understands what humans want. And so, that was the plan. And I think that was the plan that I ran 2 months ago, and it was just a matter of building and engineering it. Create a data set with detailed natural language explanations, appended to pre-existing preferences. Where the data comes from is like a whole separate question, and then afterwards getting a baseline reward model working, parallelize the training runs across a bunch of GPUs, and afterwards test the new reward model, and afterwards parallelize that across a bunch of GPUs, and then test for results. And I thought that it would be, I thought that would be mostly the process. And 2 months later, I have some building and engineering. And I think I've done a lot of the engineering work in order to lay down a lot of the foundation. So the first thing that I built is a data generation pipeline. What this does is this takes an existing preference data set, because it turns out we have a lot of those. For instance, helpfulness, harmlessness from Anthropic. They have like a whole like 160K rows or something. There's also OpenAI summarization. They have their own like data set. And it just adds an explanation. And the way in which we add an explanation is through ChatGPT. So basically, the ChatGPT API has around a limit of 3,500 requests per minute. And so Gabe showed me how to parallelize, run 300 or 500 different threads, and then afterwards ping the ChatGPT API until it literally reaches the base limit, and afterwards have like an exponential backoff function. So that way it literally just like reaches the rate limit and afterwards never like exceeds it. And so yeah, I have this. It also works with other open source models like Stable Vicuna and Claude, although they don't go as fast because they don't have, I think with open source models, I'm more limited by the amount of compute that I have. And then afterwards, I built a reward model pipeline parallelized across 8 A100 GPUs via Hugging Face Trainer and Accelerate. Essentially, there's supervised fine-tuning, which is typically a step used in reward model training. Essentially, what this means is that you have like some sort of baseline model, and then you want to specialize it. So you just train it on the preference data set to do the typical thing of predicting the next token. And this results in around 1 to 2% increased performance, so we do it. And after that, I built out a reward model training scheme for both baseline and explanation models. The way that I'm implementing it is a two-headed transformer. And it also contains settings for a bunch of other techno, like mumbo jumbo. And afterwards, the hope is that then afterwards I can, RLHF pipeline, which I can take from Corporate AI TRLX, and I want to disable or toggle on a few things, so that will require tinkering with TRLX settings in order to get specific figures that I want. And the next steps revolve around experimentation, which data sets I'm going to use, which evaluations I'm going to do, which are mostly around standard robustness evaluations, evaluations on accuracy, and evaluations on also common benchmarks. And there's previous papers that suggest that explanation-based fine-tuning makes models more robust to spurious cues, and they have various experiments that are quite interesting. So I'll be working with the first author of this paper to evaluate a lot of the things within my own reward model. So questions still remain about whether or not this would improve any of these things that we care about, like truthfulness and honesty, which is something that I ditched, but now I'm putting back up there as like maybe something if you fine-tune on, or if you build a reward model that can incentivize truthfulness and honesty, you get a model that's more truthful. Better moral understanding, harmlessness and risks for misuse, or making certain things like sycophancy, lying, and hallucination less likely, or explaining why certain preferences were chosen. These are all hopes of the project. These are all things I want to test out. These are all empirical questions and hypotheses. The hope is that it would do some of these things, or it would improve them on the margin. But even if this project goes well, empirical RLHF is not complete for safety. To illustrate this, you have the slide from Jacob's slides, which is essentially like this big monster. After it's that smiley face over there is RLHF. And the idea is that RLHF is this like nice little layer upon like a horrifying Goliath. It's only one technique within a much larger and complete safety picture. And my job is to make that smiley face smile a little bit more. I'd like to thank my mentors, Herbie, who's right there, as well as Tomek, who's in Warsaw, for a lot of their help. Without a lot of their help, and without a lot of constant like pinging back and forth on Discord, asking like sometimes dumb questions, I would have been like stuck a long time ago and not been able to do a lot of the things that I have today. And I would like to give thanks to the ERA Fellowship, as well as for Tillman for his continued support, and also for keeping me sane. And as a final token of appreciation, I'd like to present to you ERA Bingo.